Without further ado, we'll move on and hear from Jason Yu from PSI. PSI, yes?
Yeah,
okay.
PSI.
About AiiDA. Take it away, thanks.
Okay, morning everyone. I'm very happy to be here to represent the AiiDA team to share with you guys our 10 years experience on developing AiiDA. Just to make sure that people from Zoom can hear. Because yesterday I think Michael had some problems like hear me.
I'm seeing some thumbs up. I think you're good.
Okay. Yep. So first of all, who I am? I'm postdoctor from Porsche Institute in Switzerland. I'm from group led by Dr. Giovanni Pizzi, from lab led by Professor Nicola Mazzari. My journey with AiiDA started from around 2020. I'm a Google Summer Code student and contributor in a small engine project of AiiDA. And 1 year after I joined the team, and from 2022, I started leading the development of AiiDA Lab, which is a web interface that allows users to run complex scientific workflow on the browser through AiiDA. So besides, I'm also a young junior user. You may not notice that I'm this cat here. And now I'm also working on a Juliet package, pursuit potential generator, which is a DFT software for atom system, and is able to be used to generate the pursuit potential. Formal-wise, I think it's still a lot of space to, because I'm not very expert on this Juliet thing. So move on. So what is AiiDA? So AiiDA is a workflow engine with reproducibility inherent. What does this mean? I will probably first give you an example. Let's say we have a Python function is to multiply two numbers, and we decorated with this calc function decorator provided by AiiDA, and magically under the hood, AiiDA would automatically store the input, the output into the database. So after running this function, what you get is not just a single output, but everything is in the database, and you can tracing back, getting the history of all this data just by looking at the database. And then move forward a bit. Now we use this output data, and we want to use this output data to run another calculation, this arithmetic add calculation. And this time, this calculation is not just run locally, but AiiDA is able to distribute this calculation into any remote computer that you have access to. And AiiDA running locally can submit this calculation, and when this calculation finished, AiiDA can fetch the data, parse the data, and store data into the database automatically. Then we move to a more realistic use case. So this is molecular dynamic studies of solid-state electrolyte. So you basically cannot see this clear, but you can basically get the idea that there is some pre-processing on the structure, and then time step by time step you get in the trajectory. And AiiDA would just having all this information stored in the database. So in principle, if you look at the output of the final structure, then you can trace them back to getting all the data that are hidden in your calculation. And this is the example of just one structure. And in a regular high throughput calculation, then you have like hundreds, thousands of calculation having the same logic. So AiiDA can also manage this large number of calculation. Basically, you cannot see like what is actually happened, but in AiiDA, we also try to provide very handy query languages that once you're getting all this data into database, so you can using this query language to getting any kind of data that you want to continue your studies. And yeah, so I also want to mention that yeah, AiiDA began from 2014. So at that time, we decided to using more in Python. So the AiiDA core and its ecosystem, its plugins are all Python-based. And I think at that time, most of the people from computational material simulation community are using Python. And I think maybe still today now, and probably a couple of years later would be Julia, and my best wishes. Okay, so AiiDA is a workflow engine, and there's also other workflow engine. Then, what makes AiiDA special? I try to summarize into like 4 features that AiiDA probably have and other workflow engines may not have. So first of all, AiiDA is running locally in your laptop and your workstation, and the only thing needed to connect with the remote computer, remote HPC computer center is the SSH connection. This can become quite handy. I will give you one of my cases that during my PhD, I need access to one of the largest supercomputer in China, and but I cannot to run any long-run service on that computer. So I have to find some ways that I have some ways to manage the data locally, and I only need a SSH connection to the remote. Then secondly, AiiDA allowed to, which I call here is like machine report proof. Is that AiiDA would submit the calculation into remote, and it's running in remote, but locally you can close your computer, and when you start, you resume your calculation, and it will not try to start from scratch. But if the calculation happened in the remote and when it's finished, AiiDA would start from fetching the data and parsing the data. So it will not just restart from scratch. So this also became handy to me. Just in the last year of my PhD, I developed a home office and using my laptop. So I need, and there also not very good network conditions. So this became quite helpful. And AiiDA also take a very serious consideration on the data backward compatibility. Because in the design, we're having this large database. Around this large database, we want the data that produced today that can be accessible, can be visited, can be explored a couple years and even decades later. So this example that the data is being generated on 2070, one of our milestone paper published in Nature Nanotechnology. And you can see now, and I used the latest version to import the data that had been dumped 7 years ago. And AiiDA was first to try to migrate the data into the data mode that can be understood by the latest version of AiiDA. So this means that you can safely generate your data, dump your data, store your data, and then other people with any version of AiiDA, in principle, can get in the data and to explore the data in their own machine. And I think this could be most shiny futures, and I think it partly also answered the question that Oscar just talked about. So in AiiDA, we try to keep the engine part as lean as possible, and then we bring this plugin system that can support different code, not just the DFT code, but as you can see that we also support the scheduler, the Slurm, and we can support the SGE. So if you have the other new scheduler, we provide an interface that you can plug into the AiiDA and using AiiDA as a work engine to just manage the submitted job and store the data in the database. And I want to also highlight that we start having some close cooperation with Michael, and hopefully soon you'll see AiiDA DFTK plugin Yeah, and yeah, basically you can go to this URL and you can find we have a long list, nearly I think maybe already 100 plugins that in our registry, and you can see that the people start to contribute the plugins to keep on grows year by year. Yep. So there's some good features about AiiDA. However, we're still sometimes getting the feedbacks from the community. Some users told us that, well, AiiDA is still not easy to use. And even for myself as a project developer and as an AiiDA user, I sometimes feel a little bit of friction when I need to use like new features and I need to writing a new workflow from scratch. And I also ask myself, like, why I having these feelings, even we already put quite a lot of effort into introduce the usability, and then I kind of like get the conclusion of, yeah, in general, AiiDA is complex because it's a domain-specific language, and learning a new language with new syntax and new concept is in general difficult. And the two biggest gap for this usability is actually summarized as first, the static type system, which Python don't have, and we want to introduce back because we need put the data into certain layout into the database. And the second is in AiiDA, calculations are run asynchronously, and you know that concurrent programming, asynchronous programming in general is hard. Extend on these two items. First, to making AiiDA build around the database, to having this handy query language, and to having this provenance graph that you can trace in the data back to find what input you provide. So this is the pro of we having this design. However, Python is like optional. The type system of Python is optional, but for AiiDA, so if you need to define declare variables, you need to put it as like a specific type, data type, and this basic type is still like not that hard. But when you come to more complex type, like structured data and like NumPy, then things getting a little bit trickier. And we have documentation, but sometimes users need to go to find how they need to construct this type of data. Yeah, so yeah, to new users, this may be confused because the concept we bring in that once you get familiar with Python and then you go to AiiDA, then you still find a little bit of barrier. And then there's this asynchronous coroutines, because AiiDA, when you run the calculation, you having the AiiDA thread that sending the calculation into remote, but you don't want having one thread keep on monitoring this calculation. You want when it running on the remote, you having this thread keep moving and submit more jobs, and also working on like once the remote calculation finished, you can fetching the data, parsing the data. So this sounds like very like the asynchronous programming. You're having some I/O bounded calculations, and the thread running, and you send this to the I/O devices, and you're having like a Linux kernel epoch that keep on pulling things, and when it's finished, it wake up, and the thread would from that pause state and keep on working on that. And basically, I can make a one-to-one match between like a general programming language, this asynchronous programming, to the AiiDA. The concept you can find some are like quite similar. And there's a lot more technical details, and if you are interested, I'm happy to also talk about this more. Then this comes to that. So yeah, so this design is bring the advantage that as I just mentioned that we can close the computer and don't the computer again. The calculation can continue, And also this allowed us to handle thousands and millions of calculation on a single machine. Yeah, however, the problem is that we because we need in Python we have this global interpret lock, so we need spawn the multi-thread to handle the submission to communicate with the remote computer, and in between we need some communication which cores need to handle this calculation. So we use this external background service, this wrapping queue, to handle these things. But this is some service you need to run independently. So for the new user, when you need to set up an environment, so there are also some barriers. And this perspective I come from after I read this blog post. So in general, there's a problem in programming language of async IO programming is that you have an async function and you have a synchronous function, and you need to call each other. Then you need to mix up these two kind of code. Then it's become a little bit nasty. In general, there's no good ways, and in AiiDA to work around this, actually we invent another kind of syntax to work around this to avoid the user to writing the asynchronous code. So this is a decision we made that we think this makes things easier, but there's still a little bit of barrier. So this in general two large gaps for the usability. But anyway, good things and bad things. AiiDA, I think I'm confident to say that AiiDA is a good ecosystem. It's attributed to three different things. First, as I mentioned, the plugin system. So we can focus on working on these engines to make it tight and compact, and let the community develop their own requirement, the plugins, and they can then put things back and run whatever they want. Also need to mention these satellite products. One is AiiDA Lab. I will give you a demo later. And one is a Materials Cloud, which you can post your data into this platform. As satellite products, I think that these three things support each other to make things more sustainable. And third, I want to mention the discourse that last year we changed from the main list to discourse, and this making our ecosystem more alive. I'll give you an example of this AiiDA Lab. So yeah, I'll just play the video. So yeah, you open the browser, you'll see this, and you select the structure from some database, and then yeah, you can also add it to the structure a bit, and you select what property you want to calculate, XPS, even some phonon properties. Here is the phonon dispersion, and you can also have in the IR Raman spectrums, and you can see from here the vibration mode. So everything the target user of this thing is the experiment list. So they don't need to know any programming language, but open the browsers and click the mouse, and hopefully they can get in the results they want. Yeah, also the nuance is quite new things in the PSI that we have a corporate with. Okay, so before I move to the second part, any questions about what the AiiDA is? And yeah, I can pause a little bit, and then I'll continue. So it's clear that you know what the AiiDA kind of is, right? So I will move to a little bit non-technical part. So talk about how the findings and the decisions lead AiiDA into what it looks like now. So first, I want to use this slide to acknowledge the findings. You see a lot of findings, but some are like more general fundings. And I using these lines to categorize the fundings into two types. So on the above is the fundings that are more scientific fundings. I want to especially mention the MARBLE, which is 12 years fundings, the project leading by Nicola Mazzari. And this is the funding that the project that gave the birth to AiiDA and define the roadmap of AiiDA and kind of basically shaping the AiiDA to what it looks like now. So it's very, so I would say AiiDA is very scientific, academia-oriented tools. And on below, those are fundings that I say more industrial-oriented. So I think those industrial fundings like give us a couple of benefits. The first is that a lot of partners from these fundings are from companies, and so AiiDA in those projects are usually try to bridge the academias and the industrial, and so this gives us a chance to see what the industrial need from our tool and how much we can extend our tool into different fields. Some example is like this premise and the big map. So we try to use AiiDA as a workflow engine to also control the robotic system. And in these Swiss twins, we extended AiiDA as a workflow engine to be the workflow engine to the weather and the climate simulation. And also another thing is that AiiDA is not the only thing that we need to deliver in these fundings. Usually, we need working on something unrelated with AiiDA. But I communicate with people from industry. So actually, we have learned a lot of new technologies that we can contribute back to AiiDA. Take me as example, I was in this project the first year, and I learned a lot of things about Kubernetes Docker, and after that, I also put some code back into the AiiDA with this containerized technology. Yeah, I think it's in general like people as working more software in the academia that we can see what the industrial needed and give us a chance to more confident that if we didn't stay in academia and we can see how much we can go into the industry. From the team, we have some members after they go to the Microsoft, go to NVIDIA, and some go to some startup company and even create a startup company. But as I mentioned, AiiDA is still very academia driven. So I think paper is still, the publication is still one big part of to mark that whether it is a good tool or not. So over the years, I list here 5 milestone papers. So for AiiDA itself, it's we have AiiDA 1.x and AiiDA 2.x with large engine change, and the paper to describe the AiiDA engine. And we also have 2 scientific paper, the one published in the Nature Nanotechnics for the 2-dimensional high throughput to exploit the 2-dimensional materials from the experimental structures. And we have a paper just published in the beginning of this year on the Nature Review Physics, and I will give more details about this one later. So, how many times now?
Well, let's see. I think we were like 5 minutes behind, so let's call it 15 minutes.
Okay, yeah, I think it is enough. So, we're having this flagship database generated by some of my colleagues, and the database, you can explore the database to see all the details. So this encourage a lot more follow-up studies to calculate more properties and adding back to the database. So with this good reproducibility, this can inspire the more other researchers based on the work previously done. And another good decision is this plugin and the plugin registry. So I think this began from very beginning that when we have in the workflow and the people from the users of VASP, they start writing their own workflows, then we come up with people writing kind of like very similar logical workflows. And then we bring people together and we say, let's not reinvent the wheels, but we put everything together into one plugin and contribute to that plugin to make it better. So then we have this AiiDA VASP, and the plugin ideas also come from there. And also this, we have this registry to getting the plugin more exposure. So if you have a plugin, then you only need to open a PR with these 5 lines to say where your plugin is. It can be hosted in GitHub, it can be hosted in GitLab, and we will try to install your plugin and also to read the doc string and even to read the specification of your workflow and then serve it as like API documentation. I think this is quite similar as like a document.jl, as I learned yesterday. So making the plugins published more easier to getting more exposure to those plugins. So, and the plugin system actually bring us I think this is one very large benefit we have this plugin system. So people can working on their own plugins for their own code. So this is a paper published in the beginning of this year. It's collaboration work from big players from the DFT community. And from AiiDA, we try to provide a middle layer to run things, to make it run the things more generic. So what we run here is the equation of state of different structures, and then different codes can implement the interface to run this. And AiiDA in the end is just you can use this workflow to use the code as one of the parameters, and you can run like an equation state with VASP, you get this result. Equation state with Espresso, you get that result. So then this makes it possible to compare this result from different DFT code. It's also one of the major outcome of this is that with this, we also driven that DFT code to improve their implementation. We also find sometimes some subtle bugs from the DFT code. And now the DFTK, I think Michael also having some effort to using the same workflow to verify the DFTK. So I want to quote from Rachel, quote from Michael, that people compose when software compose. I think this is an example of this quote. And move to non-technical decisions. We joined the non-folks as an affiliated project from 2020. And you may not know that Julia is actually also a project under the non-folks, but it is the fiscally sponsored project, which that means that the non-folks also provide the legal support to this kind of project. But like the Flux.jl, I think it's one like machine learning package in Julia, and also the mainly if you like watch this 3 blue 1 brown in YouTube, this is a package that he used to he invented and used to make these nice mathematical animations. Those projects are less bind with the non-folks, but one large benefit from become part of non-folks is that from 2020 we continue getting the student slot from the Google Summer Code like under the non-folks. So I'm the first student working on AiiDA and Google Summer Code, and then 3 years later I become a mentor. and kind of bring some good upgrade for the async engine and also to the registry page that you see that can be served as API documentation for the plugins. And then this last year, I just mentioned that we moved to Discord. I think this is a good move because when we look around and we find Python and Julia are all moving to the discourse, and then we think it is should be a safe move. And actually, this makes our community more alive. People want to go there to ask questions, and for us, we're also happy to interact with the users. Maybe a question like, I think of a Julia molecular simulation. I would expect that I would ask questions and find the questions that already being asked. So maybe this Zulip is more a communication channel, but some forums would be also quite helpful. If I have time, just to mention the structure. So there's not all people all working on the AiiDA. Usually we want to mention ourselves like AiiDA lab, and the material scout team. We have project leaders and advisory communities. And we have people working on more core part, but we sometimes also have other scientific projects. And we have AiiDA lab team, we have material scout team, and I think a lot of more important is that we having the internal user doing scientific research that are basically using AiiDA to run the large high throughput calculations. And move to one part, the take-home message. First of all, I think working as a software library in academia, in general, there's a problem that not like the products in market, that you have like a very clear driven of the market whether you need to implement this feature or not. But usually, our main drive of the academia software is the project and the project cooperators. So for us, from start, we want more targeting to the high throughput and the reproducibility, and then more recently we find that actually the project founders want to like a new student can start writing workflows in 2 weeks, and then can benefit for like 3 months master projects. And then we start working on to provide a light version of AiiDA, but we need to also consider to not dropping too many advanced features that are already being used by the advanced users. And meanwhile, we need making this transition easier because new users would finally become the expert users, so they need more good features, and they already having some data. So we need to try to making this transition more easily without losing the data. And last story is that last week the Formula 1 is in Texas. So, and also I like Formula 1. So I'll give you a story about listen to the second drivers. In Red Bull, Max Verstappen is the first driver, and Sergio Perez is the second one. And last year, Max Verstappen is just so good that he won a lot of Grand Prix in a row. However, Sergio Perez is always a little bit of struggle with his car, and he complained about some issues with his cars. But the team tried to ignore these complaints because how come the Max Verstappen can be always so good? But the problem is that, like the team, you always have a very expert developers and very expert users, and they can always find ways to work around small issues. But so listen to second drivers, you can find small issues, and these small issues sometimes can be very crucial issues to the community. So so I think, and extend from this, I think we should listen to a wider range of users, but this in general is not easy. We need to put a lot of investment onto to times, to human resource, and to having the questionnaire, to having one-to-one Zoom meetings, to getting the feedbacks from the community. And in general, we having people love AiiDA, and we have people that don't like it too much. So we try to listen to all the range of users, and we try to listen to like the central part of the Gaussian for the advice. And lastly, I want to put this as question. So we want to listen broadly, but when we need to make decisions, who we need to listen to? Because usually in software engineer, like the design can be good in opposite ways, but if we try to take the democracy ways and put the make everybody happy, then we end up with some features that may not be so good. I don't have like a conclusion now. Yeah, so I would end up with the acknowledgement again, because in software, I think the people is the most valuable thing, and yeah, all the people from the team and the former contributors and the plugin developers and the users. So the last quote would be, if you want to work fast, you work alone. But if you want to work far, you need to work together. So I will end up here, and thanks for your attention, and I'm happy to take questions.
Thank you so much. That was great. So anyone online, feel free to ask questions, or folks in the room. Is that a hand up?
Yeah.
Jeff.
So you said you're a junior fan as well. So if you were starting today fresh, if AiiDA didn't exist and you wanted to rewrite it today, would you start in Python or Junior?
I have 6 months experience of Rust, so I would. Just kidding. Actually, we have like a more or less some discussion with, because from the team, we also have some Julia users, very expert Julia users, and he said that if I do this with Julia, he would like probably 1 year he would having a similar this, but we take like 10 years. But no matter what, I think one part of the very trusted thing in AiiDA is not the code itself, but the community we build, all these plugins. If I write new things, probably we can replace the engine. We can replace a lot of core part of the engine, but if I rewrite like in Rust, probably, I don't know, then I will still keep all these plugins. I want to support all these plugins. This is something I cannot replace.
Hi, so I have a few questions. First is, for example, in one calculation, you have so many different types of data, like input and output. For example, for input, you have k-points data, structured data, UPF data, all these kind of things. And also, for output, you have like bands data or something. How do you store that in your database? What is the structure that you have so many different types of data? How large is the database? And if people want to use your database, how do you balance the, I don't know whether, I see you have a web interface that people could probably run calculations on your cloud. If a lot of people are using that, how do you balance the cost and how do you make money? I mean, and also my second question is, when I was using the Materials Cloud API, I found you have so many different kinds of nodes that you want to traverse. So how do you, but it's not easy for me to, because you have a UUID for each different kind of node. So how do you traverse all kinds of nodes? For example, if I want to calculate the CPU time per bands in a band calculation per key point versus versus some kind of other kind of data, how do you easily traverse this graph of data and get all the data I needed in one probably single API or a few API calls?
Yeah, that's good questions. So to answer the first one, how the data are being stored in the database. Actually, in AiiDA, it's not just the database, but we call it storage. Storage having 2 parts. One is database, one is file system. So for the files, for like the NumPy arrays, we store those data in the file system. So like these 2 parts become the storage of AiiDA to host all the data. And extend a little bit on this. So the second question.
So how do you traverse the, try to get all the data?
So yeah, first you need okay. I forget to mention one thing is that you mentioned this band structure data, K points. Actually, in AiiDA, initially we are targeting onto the computational material science community, but now we have effort to remove some of these components out from the core, so to keep the core as like only workflow engine. But now you still can find this band data inside the core, but we have the effort to move it out, or we already successfully removed this potential data out. The second question about how to query these data. Yeah, in general, you need first to know the structures of how these data are being generated. So we provide this visualized way to see how the nodes are connected. And then now the effort is that you open the materials cloud, you can having these visualized things to collect the nodes and to getting what you need. And then this year's Google Summer Code, we have a student working on that to make it more generalized. You can zoom in and zoom out to see the nodes, and you can click and follow the nodes to getting what you need. But to make it more general, we need some query language, and we're having this specific query language embedded in AiiDA, but it's also not very easy to use. Then, but if you go to like the ChatGPT, actually you can get quite a nice advice like how to write in these queries to get in the data, because we already have like quite many use cases on that, but still a lot of things to improve, and we are thinking about to having some students working on some large language model to improve these queries. And we're having also some people working on the front end, the GUI, having these query builders, and you know which data you want to get in, and it will generate these queries for you to get in the data. But in the end, you're getting a database, so you need some ways to query that. But I think the language we provide is already better than the SQL language to use it.
Maybe one more question now, then we can, yeah.
I was wondering, when you talk about kind of asynchronous programming, can functions kind of be like resumable? Like I guess in Python you have like the yield type thing.
Good question.
Or are they all kind of just like pure functions?
We try to avoid this asynchronous syntax to user. So usually when you write in these functions, people write in a synchronous function. So this is the synchronous function that sometimes are CPU bounded. So when we run it, actually it will block one of these runners we are running. So it's not like maybe we allow the user to write in this yield, to write this async, but in the end we try to just let user to write in the synchronous function, and we run it as a synchronous function, but block the eventually.
Okay, so when you say like you're saving the function state, is that just like the inputs and the output?
Not really.
Is it the internal?
If I can go back to this slide, it will make things more clear. Yeah, actually in AiiDA, we try to mimic the way how general programming languages handle this asynchronous. In AiiDA, we're having a concept called process. This process is actually a state machine. And the state machine is the ancient C programmers that they programming on the asynchronous. So they have like state, and when you go back to these functions, you can resume from where you stopped. But we actually in AiiDA engine, we explicitly implemented this state machine. And on top of that, we also making this state having the persistent, so it's not just stored in the memory, because in the general language, when you close, you open that, the memory is lost. But in AiiDA, these things are stored in the database. All this checking point information is stored in the database, so it's report proof.
Okay.
We actually did these state machine things by hand. Because now modern language provide very handy it's async and await these future things to the language. But actually we did like see ways to implement the state machine.
So I think in Julia, like each of the tasks has their own thread.
Yeah.
Is that
Yeah, there's two ways in languages on the asynchronous program in the concurrent programming. One is more like a Go language, like either they have provide this virtual threading, because for the multi-threading you need to switch between the thread, which is quite costly. And one way is like you have virtual threading, then you switch like between the threads like quite cheaper. It's a Go language. I think Julia task is also in this way. But there's like a Python and so I know the Rust. There's the event loop and the runtime that driven, and you need to store the state and when it's go back, so you can restore from this state. And you can this is basically like the Python yield. You yield and you store the state and you go back in a different way to continue.
All right. Thanks a lot.